Welcome to a new section, and this time it's Unit 2, which is Big Data and Algorithms. This is Alakto Saratam with you, and we are going to be delving into big data and algorithms. This is actually, this was originally going to be like a two-part, but then I was like, you know what, let's just do it one part. So here we go. Now we need to understand that, first of all, hiding within those mounds of data is knowledge that could change the life of a patient or change the world. This is by Atul Bodo from Stanford. Um, what are we talking about today, or rather, what are we talking about this week? We're talking about big data. So, what is big data, or why do we need big data, or what is the importance of big data? We're going to talk about big data. We're going to talk about algorithms. We're going to talk about the historical development of AI. And why AI, even though it's called artificial intelligence, why is it not intelligent and why it really doesn't matter? Now, the pre-test is going to talk about the questions I'm going to ask is what is big data, or how do you define big data? Why are algorithms important in marketing and businesses? What is the significance of 1956 in AI? And what do you think will be the future for big data and algorithms? So, what is big data, or how do we define big data? Big data refers to the database datasets whose size is beyond the ability of typical database software's tools to capture, store, manage, and analyze it, by Maniaka in 2011. So, this one actually goes into the four V's, what I like to call the four V's. The four V's are volume, velocity, variety, and veracity. So, what is volume? Volume describes the amount of incoming data that is to be stored and analyzed. Velocity is two aspects. So you have, on the one hand, you have data generated at a very high speed, and on the other hand, systems must be able to store, process, and analyze these amounts of data promptly in order to be able to like utilize your big data. So your variety is the variety of the big data. It is basically um, it is the great variety of data of the world of big data confronts systems with the task of no longer processing with structured data from tables, but also with semi and unstructured data from continuous text, images, or videos, which make up as much as 85% of the amounts of data. Especially in the field of social media, a plethora of unstructured data is accumulated whose semantics can be collected with the help of AI technologies. And veracity is where all three dimensions have been utilized nowadays and actually can be mastered by companies. Veracity is the term that uses trustworthiness. It is the truthfulness and meaningfulness of big data. A lot of times you will hear garbage in, garbage out. If you have a big data and you have a lot of data, but the data is absolutely garbage, what the output is going to be is garbage. You're not going to have a lot of your output is going to be extremely bad, and not only is it going to be extremely bad, but it's also going to be, like I said, garbage in, garbage out. So what you're trying to do is you're trying to process all of these data that you have gathered from social media, from your surveys, from your um, data mining, from things like that. You're trying to gather all of this data and you're trying to process it to the best ability of your system and to the best ability of the AI. And that's how AI comes in and plays with big data. And you can find it in a variety of uses. Now, old big data, or what is not new, is the approach of gaining insights from data for marketing purposes. Um, marketing purposes, this is not new. Marketing has been notorious in using big data and especially when you come to like CRM, and especially analytical CRM and database marketing. So, database marketing or analytical CRM has been around for more than 20 years. The phenomenon of large amounts of data is equally nothing new. Point of sale, customer, and credit card. or web servers have long been producing large amounts of data. Equally, the analysis of unstructured data in the shape of emails, web form free text, or customer surveys, they are also examples of how big data is not new. How if you have been using it for a very long time, we use it mainly for marketing. Now, where it is new is actually in the Internet of Things. And um, the Internet of Things is basically a system of um, information, a system of a lot of things that come together and use the internet. That's the Internet of Things. That's kind of like the the snapshot of of the definition. It is far more complicated than that, but it's just like I said, this is kind of the snippet. It is anything that is connected to your internet, and it has to utilize the internet. That is your Internet of Things. So, what is the new thing? So, it goes without saying that the amount of data has increased immensely thanks to the Internet of Things, mobiles, and social media. The decisive factor is that thanks to the possibilities of IT and the digitalization of business processes, customer oriented points of contact for both generating data and for systematically controlled communication have increased. Added to this is the high speed at which the corresponding data is collected, processed, and used. Equally, data mining methods of deep learning and semantic analytics raise the analytical value creations to a new level of quality. So, the new things is even though we have used it in marketing, even though we have used it for customer oriented points of view and of contact and all of that, we've used it before. It the increased possibilities of IT has increased the possibilities of using big data and actually made it to where we can utilize big data better. But here's the thing is, how can you do that, or why can you do that, or how are we able to do that? It's actually through algorithms. So, algorithms, you need to understand two things. The term algorithm was typically always associated with the subject of mathematics and informatics. Today, the term algorithm is also strongly boosted by public discourse. The rather innocent, somewhat boringly thusly connotated term has now become a phenomenon that, against the background of the fourth industrial revolution, and the threatening front of the substitution of jobs is being discussed critically in public. And the term used for the new version of algorithm, the term is fog bomb. That is significant. So, why do we keep going back again to mathematics and informatics? Mathematics is a universal language. It is most of your computer sciences and most of the algorithms and most of the big data actually stem out of mathematics. Most of your professors actually come from mathematics, the ones who actually came up with whether mathematics or sociology, one of these two, but mainly you've got a lot of mathematics in the field of science. Again, math is the universal language, so that is why we have that's why even algorithms, if you remember, you go back to your school years, or even not your school year currently, if you're in school currently, if you are doing algebra and you are doing geometry, you hear the word algorithms a lot. You'll be like, hey, this is the equation of the following, and this is the algorithm of the following, of whatever it is, the factoring or multiplication or whatever. And it's basically that's where it comes from. So, what is the power of the algorithms, and why is it powerful? The reason why the power stems from the fact that it is the difference of the structures of the algorithm and the complexity of the algorithm. So, the more structured and the more complex, the bigger the impact you have on your on your businesses and on the autonomy of the business um, of the AI. So, the correlation between algorithmics and artificial intelligence is the more complex your algorithms, the better and the more business impact and the more autonomy your AI. It started with the first algorithms we ever done in computer was rule based. It's basically a your calculators, your simple like conversions and things like that. And then came the knowledge based. The knowledge based ones are the um, your your Britannicas, your world history, your I'm not going to say Wikipedia because Wikipedia is an interesting take. Wikipedia, we'll get to Wikipedia later on, but Wikipedia is kind of interesting. um, because I was actually an experiment with Wikipedia that's pretty fascinating. But like again, it's going to be one of the supplements. I'll get into it more in the supplements. Um, but your knowledge base, yeah, and then after that, which is currently what we're currently having in our systems, is the narrow AI, and our artificial intelligence. And this is like doing, it still is artificial intelligence, but it is the very basic of artificial intelligence, and it's not doing exactly what humans are doing. And then you go to the general AI, which is more human like, and then the super AI, it exceeds human thinking. That's a super AI. um, there was a supplement in Unit 1 that did delve more into the truth, like that gave you the definitions of all of them and what it is. Now, the super AI is the second term for super AI, is actually autonomous, not autonomous, humanoid AI, artificial intelligence. And this is basically the power of algorithm, and why algorithm is important. So, moving from there, we go into the trying to see what is AI. How do you define AI? And the how you define AI is, in simple terms, is will machines be intelligent one day? Will machines be able to think like human? That's kind of like the simplest of definitions that you can get for AI, or at least how they try to interpret AI in the beginning. The way they tried to interpret it at the beginning was through the information that, yeah, can machines think exactly like humans? But then here's the thing: is how do you define intelligence? Because you're trying to say, you're saying is, I want to think exactly like humans. I want the machine to think like humans. But how can they think like humans unless they have human intelligence? So let's define what intelligence is. We have to first define what intelligence is in order to quote unquote recreate it or try and be able to emulate it. So the definition of intelligence, at least at the beginning, the core statement of is the ability of abstract and reasonable thinking and to derive the purposeful actions from it. This is as per Juden 2016. And in essence, it is a general mental ability that, among others, covers recognizing rules and reasons, abstract thinking, learning from experience, developing complex ideas, planning and solving problems. That's plug also 2016. That is the definition of intelligence. Now let's leave artificial intelligence and let's dive into the history. What is the historical development of AI, and why are we so bent on trying to make Sophia's and other things like Sophia? Well, why did we do that? Is it a novel idea? Is it like the person who came up with robotics? It's in a novel idea? Actually, no. Actually, we actually started thinking about AI way back in 1943. Um, the Americans Warren Mucklow and Walter Pitts published the first work dedicated to the field of AI. Um, they're the ones who first started this one. This is Russell North. Now, based on knowledge from the discipline of neurology, mathematics, and programming theories, they presented the so-called McGraw-Pitts neurons. So what they did is they tried to emulate the neurons that are fired in our brains, how neurons work in our brains, how this one, the neural connections in our brains. That's exactly what they tried to do. That's what they tried to emulate. So what that means is they described for the first time, as an example, the structure of artificial uh, neuronal uh, networks, the setup and structures of which are based on the human brain. So this is what they tried to do. After that, and after that, the most significant article, and the one who's actually being called the quote unquote father of AI, is is Alan Turing. And Alan Turing um, it was actually like had a like he had before he started delving into the AI, or like the computing machinery and intelligence, which is this is the article that's coined to be the father of AI, or the reason how we got the AI is from computer machinery and intelligence, and that was in 1950. Um, Before that, he had already given speeches on AI at the London Mathematical Society in as early as 1947. Now, understand that we're talking about a huge leap of faith, a huge thing. And the Turing test is the test that says, hey, can this thing actually think well? Can this thing actually beat humans? You're gonna have the Turing test. This is up till now. And up till now, there's very little computers that actually pass the Turing test. So, what is the computing machinery and intelligence, and why is it significant? So, computer machinery and intelligence, in this paper, was the Turing asked the critical questions of AI. Can machine think? In addition, in the article, he presented his ideas according to the Turing test named after him: machine learning, genetic algorithm, and reinforcement learning. Can machines do that? So the term artificial intelligence was first spoken of at the conference held at Dartmouth College in Hanover in the U.S. state of New Hampshire in 1956. This is why it's very significant. 1956 is extremely significant. I will talk more about that. So now let's go now. Let's talk now about 1956. So again, term artificial intelligence. The first time you speak about it was in the Dartmouth College in Hanover in the U.S. state of New Hampshire. This is in 1956. This invitation of John McCarthy. That's the invitation. That's at the invitation of that one. You had leading researchers from America come together there in the 2 month workshop. So 1956. Now we have 2 month workshop in 1956. Subjects such as neural network, automatic computers, and the attempt to teach speech to computers was to be handled. Because you had all of these researchers, you had all of these scientists, you had all of these uh, people that are mathematicians that are trying to emulate the human brain and emulate the idea of human brain. This is why you started getting the first version of AI, or the first version, and there was like the early enthusiasm, and there was a speedy disillusion from 1952 to 1969. Um, so 56 starts with the workshops, and then the Turing test is to establish human-like intelligence in a machine. So to this end, a person communicates via text chat with two people unknown to him. One is human, one is machine. If the human test subject can actually uh, figure out which one is the computer and which one is the human, they fail the Turing test. And this has to be by like 30, like it's more than 30% of the series of short conversations. Now, if he can't, then it passes the Turing test. So, in the years followed from the Dartmouth conference, great enthusiasm about the future development and success of artificial intelligence proliferated. This is what the later winner of the turnaround and Nobel Prize in Economics, Herbert A. Simon, postulated in 1958. Herbert A. Simon is a name that you're going to hear in business and in computers for so much. You're going to hear him like over and over and over and over. Herbert A. Simon is the godfather of the idea of actually turning design into science, and the ability of turning of science is scientifying design. From there, you actually he actually puts lays the foundation of the idea of, hey, if you can actually turn design into science, then we can actually standardize what design is and how design is, and then use that one and standardize actually what creativity means. Therefore, feeding back into the idea that, like, it feeds back into like different ideas, whether it's later on in marketing, he's actually going to be the guy who comes up with the idea of design thinking in marketing. But this is for a later class and a later thing. It is, like I said, it is one. He is a name that is to be known. He is. Everyone has to kind of know who he is, and I'll talk more about him. Maybe in one of the supplements or not, I'll talk about him more because he's quite a fascinating personality. So, after that comes in the 1969 to 1979. This is kind of like this is your knowledge-based systems, uh, and it's your kind of your first taste in commercial success with knowledge-based systems. So methods used up till now, also called weak methods, where search algorithm combined elementary substeps to get to the solution to the problem. We're not able to solve any complex problems. For this reason, the approach was adapted in the 1970s. Instead of programs whose approaches can be applied to a large number of problems, methods were developed that use area-specific knowledge and methods of the respective specialist field. In this purpose, complex rules and standards were formed within which the program arrives at the solution, the so-called expert systems by Russell and Norvig. Russell and Norvig actually, the reason I keep saying Russell and Norvig 2019, during these are the people we're citing. So these expert systems basically relied on the fact that you had um, experts in the field come into the programming, and they get the programming from there. So the so-called expert systems were meant to bring about success, especially in the fields of speech recognition, automatic translation, and medicine. It really did not work, so you end up going back in history, and history starts repeating itself. So the return of neuronal networks and the ascension of the AI to science. That is the 1986, and this is where you start getting also in 1986 and 1996 as well. You start getting a lot of like the big ones, the really grandiose steps and the grandiose the gigantic, like the euphoria of around AI. So so anyways, so 1986, and you start getting like what they call is the AI winter. So the psychologist David Rumelhart and James McClelland revived in an article interest in the back propagation algorithm that had already been published in the 1969. So what they did is they took all of that information that they got in 1969 that came out of like the years that passed after like the 1956 and the Dartmouth conference. They took that and they're like, hey, we can actually apply those informatics and those different various like problem solving into psychology and into the problems of informatics and psychology. So this caused your research to kind of shift back and go back to neural networks. Uh, and the two key branches of AI that came out of that was the symbolic logical approach that pursues the top-down approach and systematically links expert knowledge as well as codifies with the help of complex rules and standards to be able to make conclusions. That's Russell Norvig at 2012. And then the one that comes back again, that we haven't seen up till now and comes back again and gets revived again, is the neuronal um, AI whose methods are geared on the way the human brain works. So this approach is responsible for the current euphoria around AI. The current euphoria we have currently in AI, that's actually the stem of it or the root of it. So neuroinformatics deal with the part of the AI as um, with the same name. So what it does, it has been able to make notable progress in the last 2 decades with the help of other scientific disciplines such as psychology, neurology, linguistics, and cognitive sciences, and has thus attracted attention to itself from the business world, politics, and society. So what they did is they decided to, hey, you know what? We're not going to just like look at AI as like mathematics and we're going to look at it from like a pure like scientific method. No, no, no. We're going to actually start using that and start like we're not even with commercialization. We're going to use commercialization as expert. Oh no, we're actually going to use AI and we're actually going to apply all of these other different disciplines, all of this other different things from around the world and start applying it to AI, which is the key point that actually was lost. And this entire time they've been trying to emulate human brain and yet they have not given the AI the capacity to actually do like what human does, and that is we as humans, we're not one trick pony. We learn a lot of other things. We don't just learn language, and we don't just learn mathematics, or we learn all things. We learn language, we learn math, we learn mm, language so we can communicate, mathematics so we can actually do simple mathematics and simple addition and subtraction. We learn algorithms, we learn all of these things, all of these different things. And then when we go to like universities or we go to like higher up or even when we go to our careers, we're still learning and still honing that skill set that we had from back when we were kids, back when we started, and we're like we're honing and like like honing and shaving off the stuff that we don't. We our brain does it, like our brain does that automatically. It shaves down like, hey, we don't need this one, we need to concentrate more on this one, so it puts more effort on the stuff that we need. The rest of the stuff is like, we really don't need this one. It's just like it's just dead weight, so on and so forth. And that's basically what people have forgotten needs to be done to AI in order to emulate humans. And that is the breakthrough you get. Um, After that, in the 1995 to today, you have another again machines. You have the machine thinking. You have artificial intelligence that is equal to a human, the development of it, sure. And then you've got the bigger things. You've got the Go Alpha computer that beat the world champion in Go. You had Kurzba, um Kurzba, the chess one, Deep Blue, with beating the world champion in chess. These are all things that kind of like start, hey, you know what, we need to start concentrating more about the AI. And then like the biggest thing that came out of this entire thing is the idea of a human level AI, HLAI. This one is the first information or the first breakthrough in super AI, in AI that is more intelligent than human. That is basically what it is. So going from there, why is AI really not intelligent and why that does not matter? Um, as we can see with the evolution of AI and the evolution of what AI does and what AI has done for you is two things. We've learned that AI, as the years have gone by and as the years have continued to go by, has become more complex, and we started going more and more into human intelligence, artificial intelligence, or human-like artificial intelligence as the years go by. But here's the thing: is it took us a very long time before your algorithms began to be able to get less error rates than the humans. It's reached like 2015. So from then to like 2015, you had it to where the artificial intelligence wasn't really intelligent. But it doesn't matter because, as you can see, with 2015, your error rates in your algorithmic error rates has gone down, has gone significantly below 3%. Not only that, but your artificial intelligence itself is because it keeps learning exactly like humans are. It keeps learning, and because of that, it actually keeps getting better. So it really doesn't matter if AI is intelligent or not because you don't need it. Your algorithms are getting shorter. Your AI is getting more and more human like, and you're going to end up with having like more human like AI. Now, is that a good thing or is that a bad thing? It depends, honestly. It's not a big deal in terms of like certain jobs. Of course, there are other jobs that have been um, threatened by AI. If not, there are jobs like the manufacturing jobs that have completely been replaced by robotics and replaced by AI. But is that a bad thing, or is that a thing? The ethical part of AI, we're going to talk more about it in next class with the robotics. So we're going to talk about the ethics of AI and the question of is it really important, or is it really important to be able to do the AI, or is it really important to actually start working on the AI or to start dealing with the AI? Is it really that important? Now, with the activity, I'm gonna give you 10 minutes for the activity. I want you to write down what you have learned in this class. What do you want to learn more about? What is it that you're looking for? Why are you looking for these things? What is the most important thing you're looking for? And I need to not only that, but I needed to hypothetically create an AI that if you're going to create an AI, or if you're going to create human level AI, what is it going to be and what is it going to do? What field is it going to do? Take about like 10 minutes to do that, and then after that, let's discuss it in the comments down below, and we can discuss all about it. Um, this is the end of this class. So what we're going to do is the references is coming up next. These are the references, um, Dundee and uh, Dundee, and then like either ones, and these are all the references. I'm actually going to copy it and put it down in the description below. So what are we going to learn next week? Hopefully my voice will not be like I'm doing much better with the whole coughing thing, so hopefully my coughing will kind of stop, which is good. But we're going to learn about robotics. Expect next week to be a significantly longer a much longer lesson in class. We're going to talk about robotics. We're going to talk about the ethics of AI. We're going to talk about more about like we're gonna go more into like the Internet of Things and what the Internet of Things is and why the Internet of Things is so important. We're gonna talk about all of that and why is it important? Why do we need it and things like that. So that's what we're gonna do about it. So again, let's go back to the post-test. So what does big data mean? So big data, like we said, is the amount of data that is we're unable to store it and process it with current um, data softwares. So why are algorithms so important in marketing and businesses? Because this is how they make the data work, and this is how they make the data actually improve by the ability of turning your data um, into something useful, so that you don't have the garbage in, garbage out. So what is the significance of 1956 in AI? This is the first time you have the spoken coin of the AI, and also not only that, but it is also the first time you get the sorry, excuse me. It is the first time you get the it's the Dartmouth conference in New Hampshire, and the reason why AI is so popular, and it's kind of like the push of AI, the reason why we have AI. So, what do you think will be the future of big data and algorithms? My own opinion, I'll leave it up to you, but this one is kind of like an open-ended question, and it's more. My opinion is the algorithm, as the algorithm error rate is going down, we're going to reach to a point where we're actually going to have the veracity of big data, and it's going to be trustworthy, and it's going to be able to um, help you a lot as humans. Again, as human beings, we enjoy doing making things easier for ourselves, and we prefer to have things easier for ourselves. That's kind of how we are as humans and as human beings. So that will be the case with the big data and the algorithms in the future. Um, Thank you for watching. Don't forget to comment below. And this is my email and my work number. If you want to do this, you can. Um, Also, I wanted to know more about what would you like to do for next week. how would you like to do things better next week? How would you prefer to do things better next week? Now, normally, how I do these courses is I actually have like real life people in front of me, and we kind of have like a discussions of what we do, how we do things, and why we do things a certain way. So I'd like to do that with you as well. And I would prefer to do that with you. If you have any suggestions, what you like to do, please let down in the comment below. Let me know. Um, Also, if you need something to be changed, something to be added, I'll do that. I'll be more than happy to do that, and I'll enjoy doing that with you guys. Again, thank you so much for watching, and thank you so much for tuning in. Next week, we're going to talk about robotics, and I like to start out.